All right, lesson 22, March 15th through the 19th. So we're going to be looking at multiplying and dividing expressions with radicals. So we're going to just kind of dive right into this. You should have already learned a little bit about radicals. That is the square root of something. All right, so let's just kind of look at this. Review of square roots that are perfect squares. Guys, if you remember what a square root is, then if I'm looking at a perfect square, that is something times itself. So if I'm looking at the square root of 17 squared, then that would be 17. Alright, because if I'm multiplying 17 times itself, then the square root of that would be 17. Alright, let's look at the square root of 5 to the 10th power. Let's think about this for just a second. 5 to the 10th power can be changed just a little bit because I want to simplify this. So I can do 5 squared times 5 squared. That's 4, 6, 8, 10. Alright, so I can rewrite it like that. What is the square root of 5 squared? Well, that is 5 times 5 times 5 times 5 times 5. Alright, and I don't have to multiply this out. I'm just going to say that it is 5 to the 1, 2, 3, 4, 5th power. Alright, let's look at this one. Square root of 4x to the 4th. I can rewrite this as the square root of 4 times the square root of x squared times the square root of x squared. What is the square root of 4? In other words, what times itself gives me 4? That would be 2 times x. I'm going to put the dot there because x times x is x squared times x. So I get 2x squared. Complete parts A through C. Compare the value of the square root of 36 to the value of the square root of 9 times the square root of 4. Alright, so let's look at the square root of 36. Well, what times itself gives me 36? 6. We'll take the square root of 9 times the square root of 4. The square root of 9 is 3 times the square root of 4 is 2. What does that give me? It gives me 6. So the value of the two expressions is equal. Alright? We are looking at equal values there. Alright? Make a conjecture about the validity of the following statement. For non-negative real numbers a and b, the square root of ab is equal to the square root of a times the square root of b, and explain. It's valid because of the problem that was just completed. So the square root of 36 can be rewritten as the square root of 9 times the square root of 4, because 9 times 4 is 36. And we figured out that the square root of 6 was 6, or the square root of 36 was 6, and the square root of 9 is 3 times 2 is 6. So it's valid. I can rewrite my square roots to figure out my problem. Does your conjecture hold true for a is equal to -4 and b is equal to -9? Well, let's look at this. let's do the square root of negative 4 times the square root of negative 9 gives me the square root of 36, which is equal to 6. But can I find the square root of negative 4 times the square root of negative 9? I cannot do square roots of negative numbers, so therefore it is not true. Because we cannot find the square root of negative 4 times the square root of negative 9. Alright? Complete parts A through C, and then compare the value of the square root of 100 over 25 to the value of the square root of 100 over the square root of 25. Alright, so let's look at this for just a second. Let's take the square root of 100 over 25. Guys, what is the square root of 100? That is 10 over the square root of 25 is 5, which is 2. Now let's split it up. The square root of 100 is 10. The square root of 25 is 5. It's 2. So what do we notice? The conjecture, the value of the two expressions is equal. Alright, it is equal. Make a conjecture about the validity of the following statement. For non-negative real numbers a and b, when b is not equal to 0, the square root of a over b is equal to the square root of a over the square root of b. Alright? We can, once again, because of the problem that was just completed, it is valid. Alright? It is valid because of the problem we just completed. We proved it. Does it hold true for a is equal to negative 100 and b is equal to negative 25? Well, let's put those in there. So negative 100 over negative 25. Guys, I can reduce this. A negative divided by a negative is a positive, so that would be 100 divided by 25, which is the square root of 4, which is 2. Alright? So then let's put it in as separate. Once again, I cannot take the square root of a negative number. Alright? So it is not true. Because we can't calculate the square root of negative 100 over the square root of negative 25. Okay? Alright, so definition of a square root. We got to make sure we remember this. If x is greater than or equal to 0, then the square root of x is a non-negative number. Alright? In other words, I can take that number and multiply it times itself to get my x. Alright? So let's think about this. For example, let me get a sheet of paper here. If I am taking the square root of 12 squared, that would be 12 for any positive squared number. Alright? Now, here's something else that I can see. Alright? And that is if a is greater than or equal to 0. What happens if a is less than 0? Then the square root of a squared may equal negative a if a is less than 0. Alright, so let's look at this one. The square root of negative 5 squared. Well, negative 5 squared, negative 5 times negative 5 is 25. So, therefore, the answer would be 5. Alright? Alright, so, let's go ahead and just kind of look at some of these problems here. No, I'm going to back up for just a second. Let's do what happens if I want to look at the square root of 75. Alright, if I want to look at the square root of 75, then here's what I'm going to try to do. I'm going to see that 75 is not a perfect square. So I want to see if I can figure out a way to rewrite this so that way I do have a perfect square. We all know that 75 is 25 times 3. So I can rewrite this as the square root of 25 times the square root of 3. 25 is a perfect square. Alright? What is the square root of 25? That is 5. 3 I cannot do a square root of, so my answer would be 5 square root of 3. Alright? Alright. Let's look at this one. What if I want to do the square root of 3/5? Alright? I can look at that as the square root of 3 over the square root of 5. We've already proven that we can do this. Alright? So we want to write an expression that is equivalent to the square root of 3 times the square root of 5. By doing that, I'm going to multiply everything times my denominator. Alright? So the square root of 3 times the square root of 5 is the square root of 15. And the square root of 5 times the square root of 5 is the square root of 25, which is 5. Alright? Alright, let's look at another one. Alright, let's say we found the scale factor of the dilation to be 1 over the square root of 2. When he compared the answers to his friend, which was the square root of 2 over 2, he told her that one of them must have made a mistake. Show, work, and provide an explanation to prove that they are both correct. Alright? Well, let's look at this. So, he got 1 over the square root of 2. She got the square root of 2 over 2. Let's multiply everything by the denominator. 1 times the square root of 2 is the square root of 2. The square root of 2 times the square root of 2 is the square root of 4, which is 2. They have the same answer. Alright? Alright. Guys, I'm going to have to make a second part of this video because I actually have a class getting ready to come in. So make sure you watch the second part of the video in order to finish the lesson.